and welcome back to Atman Unlimited. So in the last couple of weeks, we've had a couple of viewers that have actually purchased their own Fadal machines. We've also had some viewers that have asked questions about purchasing and getting ready to purchase an older Fadal machine. So that has led to requests on a general operation video. Now there's already some good videos out there on YouTube on little snippets of operating a Fadal. I'm going to try to make this video as inclusive as possible, which unfortunately means it's probably going to be on the long side. But we'll go through everything from startup to putting tools in the machine to running a program and then shutting it down and putting it to bed. Okay, so let's get the machine fired up and we'll start with how to load tools. Okay, so if you're facing the machine, we are on the left side of the rear of the machine. Now every Fadal that I've seen has a disconnect on this side of the machine. So the first thing that we're going to do to power up the machine is we're going to turn on the main disconnect. And then that will power up the major drive circuits and the step-down transformers inside the power cabinet. So let's turn this on. Now what I do is I just wait a couple of seconds for all the fans to come up to speed and for everything to start loading up. There's two transformers in here and the initial inrush is quite a bit on them, so I wait a couple of seconds, and then there's a green CNC power button at the top here. Then we'll press that. Now what that does is it energizes all of the computers, the axis controls, etc., etc. You just heard the contactor for the main spindle drive kick in. So then you press this button. So now the machine is powered up and ready to go. Now also you want to make sure that you have air pressure to the machine. So the machine needs compressed air to operate. Right underneath this power disconnect, just out of the view of the camera, is a pressure regulator. And then there's an air supply. So you always want to make sure that your air is turned on and you're at the appropriate pressure. So we'll do that. My valve's up here. Okay, so the machine's powered up. We press the green button. We got our air on. Let's go over to the front of the machine and we'll talk about how to cold start it. We're back at the front of the machine. We just powered it up. Now we have to do what's called the cold start procedure. So on the Fadal machines, all of the position sensors for the axis positions are all relative. They are not, I repeat, they are not absolute position sensors. So every time you turn the machine off and turn the machine back on again, you have to tell the machine where it is in its world. Okay? So there are three flags, one on each axis, and those are the cold start position indicator flags. You must make sure that those flags are aligned correctly before you execute the cold start position. Now, what do I mean by lined up? They have to be lined up within 1/2 of a turn of the ball screw. So the way that most of the Fadal machines position is they have a resolver or they have an encoder on the servo motor, and then that has a positional offset to it. So as long as you're within 1/2 a revolution, what will happen is the servo motor will initialize and it will go back to its 0 point that it knows. So you just have to make sure you're within that turn. Okay? So then after we know we jogged our axes to the cold start position, if they're not there already, then we can go to the terminal and we'll enter in CS to cold start the machine. So let's do that. And then it's going to ask you if you want to move to the last home position. I'm just going to say no. Okay? So now the machine is started up and it's ready to go. It has its 0 position, its machine coordinate 0. Okay? This is very important because if you get the Z access height wrong, when you go to do a tool change, you can crash your tool changer. So it's very important that you cold start the machine correctly. In addition to the tool changer, the Fadal machines don't have any limit switches on any of the axes. They use what's called soft limits. So the controller knows how much travel there is in the axis, and it relies on you cold starting the machine correctly so that it will then limit the range of travel to within what the machine can do. So if you offset the XY on cold start, you can crash the axis into the end stop. There's hard mechanical end stops that you could hit. Okay, so now that we got the machine cold started, now let's go over how we put some tools in the machine. So there's two main ways that you can load tools in and out of the machine. The first way is pretty self-explanatory. You hold on to the tool holder. Now you always see me using a rag to handle my tool holders. I just do that to keep my grimy, corrosive fingerprints off my tool holders. So grab the tool holder. Now when you grab the tool holder, make sure you grab it below the gauge line, or the groove here, so that you don't get your fingers pinched, and never grab the cutter, because then you'll slice your hand open. Okay? So get a good hold on it, and then there's a button on the console called Tool In Out. And if you press that button, it's going to release the drawbar and the tools shoot down into your hand. Okay? So that's the first method. Now you can replace the tool you just removed with whatever tool you want. Now, if you notice on category 40 tapers, one notch goes in deeper on one side than the other side. The Fadal spindles are set up to use either Cat 40 or BT 40, depending on how you have your tool changer configured. So the notches really don't have a bearing. It will go in the spindle either way, unlike a true 40 taper spindle, which your tools will only go in the spindle one way. You can put the tool either way in the spindle. I normally put it so that the deeper notch is facing the tool changer. So then if I want to put this tool back in, I can just press the tool in out again, push it up into the spindle, and then release the button. And now it's locked in. Okay? So that's the first way that you can take tools in and out of the machine. The easier way to do this, if you have a lot of tools to load, is on the console in the manual mode, okay, not the MDI mode, but the manual interface mode where it says enter next command, you type in TC, 1. That's tool changer, 1, and you're telling the machine that you want to open the tool changer and keep it open. So we'll type in TC, 1, and then hit enter. Okay, now it's going to orientate the spindle, bring the tool changer in, and lift the spindle off the tool. And it's going to stay like that. Now, what we can do is there's two more buttons on the console. One of them is called turret clockwise, and the other one's called turret counterclockwise. Those two buttons will rotate the tool carousel for you. Okay, so here's counterclockwise. So if I wanted to put a tool in tool pocket number 21, I can just rotate over to that empty spot, pick up another tool, and then just slide it into the tool clip. Okay? Now I can add or take out as many tools as I want like that. Then say I want to go back to whatever tool I want. You know, this is tool 1. I can hit manual button, and then what it will do is it will pick back up that tool and then take the carousel away and park it. So we'll hit manual. Okay? So those are the two methods that you can easily put tools in and take tools out of a Fadal machine. The next thing we want to talk about is, once we have all our tools in, what's the best way to set tool offsets? So let's go over that. So I've made some videos in the past specifically on how to measure your tool offsets, but I never really showed how to enter them into the machine. So I've made a couple of videos using this manual tool presetter. And basically this tool presetter is just a 2-inch tall block with a depth gauge on it, or height gauge on it. Okay, so you can, when it's reading 0, that means your tool is exactly 2 inches off of whatever surface that this is sitting on. So I put this on the table, and then we are going to use the tool utilities to set our tool offsets. And this is a pretty cool utility if you don't have a tool setter probe on the machine. You can set tool offsets pretty quick. So if you want to see the tool offsets on the machine, you go over to the console and you type in DT, and that stands for Display Tool Table. Okay, so we'll type in DT, hit enter, and there is our current tool offset table. Now at the bottom of this screen you have a couple of options. You can enter in a new value for a single tool manually, so if you already know what the offset is for that tool, you can type it in. You can modify a value, so if you're getting some wear and you measured a part and you want to shift that value a little bit, you can do that. You can do a mass modify, and then there's the utilities number. So that's number 4. So we're going to press number 4, and then what comes up on the screen is it tells you which tool number is currently in the spindle. So tool 20 is currently in the spindle, and then it also tells you what its current values are for diameter and length. And then it asks you for a starting tool number. So if you want to do one tool, we're going to enter in a starting number of 20. If you wanted to start with tool number 1 and do it up to tool number 10, you would enter in a starting tool 1. So we're going to enter in 20. I'm just going to do 1. And then it asks you for the ending tool. So if you wanted to do tools 1 through 10, you would type in a 10. We're only going to do 20, so this is going to do 1. We're going to start and stop the same tool. Okay? Now it says tool setting options. How do you want to measure the length of that tool? And you can either choose to use a probe that you have in the machine. You can mount probes on either side of the table in these machines. Or you can choose to jog to a position. So we're going to do this manually, so we're going to say jog to position, number 1. Then it asks you for your height block size. So because we're using a 2-inch tall tool presetter, we're going to type in 2.0. Okay, then we hit enter. Now we have the tool setting options. So here, if you want to enter in a diameter, we can hit number 1, and it asks you, what's your diameter? Say this is a 1-inch tool for pretend, because there's no tool in there. Okay? Now it would store the diameter. And then you can say locate length. So we can hit number 2, and then it says press jog, and then you can move to the height block. So we press jog, and then now you can move your Z down. You know, you'd move it down to your height block. And then when you get to the height that you want, where you're going to say, okay, that's 0, then you hit manual. Okay? So you hit manual. And now what it's doing is it's waiting for you to say, yep, I'm out of the way, my hands are out of the machine, push the start button, and then I'll change to the next tool. So I'm going to push the start button. Okay? So now the Z height will go back up to its tool change height. And then if we were doing more tools, it will automatically change the tool for you and then put you back into that same screen where you can enter the tool diameter, jog to the next tool offset. And you can see how using this utility, you can very quickly crank through all of your tools if you're doing this manually and get all your tool offsets done pretty quick. Okay? That is how... That is the easiest way to set tool offsets manually in this machine. There are subroutines for measuring the tool lengths. There are also subroutines in the machine for detecting tool breakage, but you need to have a tool setting probe. I do not have one. Eventually, I think I'm going to get one. When I get one, I'll make a video on how to use those subroutines. But without the probe, it's kind of hard to make the video on how to use it. Okay? So that's tool offsets. Once we got our tool offsets, the next big thing is work offsets. So let's talk about how to do work offsets. Okay, before we get into the work offsets and fixture offsets, that's your G54, G55, G56 type numbers. Let's talk real quick about the Fadal way of doing these offsets. So Fadal has 3 layers of offsets, and it can be a little confusing at first. I tried to make a couple of videos before on how I use these different layers of offsets. The first layer is called the machine coordinate system. And that's how the machine keeps track of its body parts, okay? It's going to make sure that your X and Y don't hit the end stops. It's going to know where to place the Z when you go to do a tool change. It's going to make sure the Z doesn't hit the end stops. That is what you're setting when you do this cold start procedure at the very beginning. The next layer down is something called the tool coordinate system. And the tool coordinate system is a set of offsets that will shift and affect everybody else below it. So if you have tool offsets set, and then you shift your tool coordinate system Z down 1 inch, it's going to shift all of your tool offsets and everything down 1 inch. Okay? If you move X and Y and you have fixture offsets, it's going to shift all of your fixture offsets by whatever you put into X and Y. So it is a master shift of everything else below it, which are your tool offsets and your work offsets, your G54, 55s, etc. Okay? Some people choose to use the tool coordinate system, some people do not. Now the tool coordinate system is also the position that the machine's going to move when you call a G28. Okay, so you can see how you can affect your methodology of doing your work by using these different offsets, differently. So I choose to just leave the tool coordinate offsets where they are. Now there is one case that I found the tool coordinate system offset to be very valuable. If you have a large fixture plate that has many part locations on it, so you're making 20 of the same small part, and you know the location of each one of those parts, and you write down all of those fixture offsets, okay? When you take the plate out and then put the plate back in, rather than relocate all of those offsets that you already know where they are because the plate didn't change, you can relocate the tool coordinate system XY offset, and then all of your fixture offsets will be valid again. So that is one definite use case for the tool coordinate system offset that I have used. So it can be quite handy. I don't ever shift the tool coordinate system Z because I like having my tools referenced to the table. That's the methodology that I chose. Okay? To set the tool coordinate system, that is where the set X, set Y, set Z come from. So if you want to shift, the X 1 inch, you'd move it to 1 inch and you'd say set X and it would zero it out, or set Y and it would zero it out. Okay? So it's those set X, set Y commands that are affecting the tool coordinate system. Okay? So now let's talk about and show you the utilities to set the work offsets. So after our tool offsets, we're going to do work offsets now. Now again, just like with everything else, there's two ways to do this. One of them is a manual way to do it, the kind of way that you would do it on a manual machine. And the other way is by using, again, some of the built-in utilities, which are very useful. So let's talk about how to do it the manual way first. So a lot of people starting out are going to use an edge finder. To use an edge finder, we need to turn the spindle on. We need to preset the RPM that we want the spindle to be at. Okay? So to do that, we need to go into the MDI mode, or the manual data input mode. On the Fadals, if you just keep pushing the manual button, it will toggle in between the command mode, where it says enter next command, and the MDI mode, where you can control the machine manually. So we'll press manual, and now we're in MDI mode. We get an axis position display. It's in G90 mode. It tells you what tools in the spindle and what format is in effect. Okay? So then if we want to spin our edge finder at 500 RPM, we would just use standard G codes. So S500. The very first command you enter, it waits for you to push the start button, so we'll push the start button. And now it's going to set up the spindle to operate at 500 RPM. And then we want to tell it to turn on and clockwise, so M3. So now the spindle's on and it's spinning. Okay? To stop the spindle, there is a button on the console that says spindle on off. So you can press that button and it'll turn the spindle off for you at any time. Okay? Now, if you want to, and do this manually, we can just go into jog mode. Now we're in jog mode. We can use our dial and our axes selectors to move around our axes, and we can take measurements. And we can measure and then figure out what offsets we want to have. Now the spindle's off. So how do we turn it back on? Well, if you press that spindle on off button, it won't turn the spindle back on. Okay? There's a 2-button press lockout so that you can't accidentally turn the spindle on. So if you press the shift key on the right hand side of the keyboard and the spindle on off key at the same time, it will turn the spindle back on for you. Okay? So shift and then the spindle on off button will turn the spindle back on. So now you can use your edge finder, do whatever you need to do, take some measurements. You can write the stuff down, you know, on a piece of paper, however you want to do it. Okay? So this is all about getting your work offset numbers that you need to get. Okay? When we're all done, we can exit out and press the manual button and go back into the command screen. So then once you have your work offset numbers, now we need to enter them in. So just like we did with the tool table, we use the display tool, DT. We're going to use DF, or display fixture. Okay, so DF, enter, and now it's going to show you all the current fixture offsets that are in the machine. And you can do a new value, you can modify a value, or there's also, again, a utilities page. And the utilities for the fixture offsets are pretty good. They're nice, they work well, and it will save you some time if you don't like writing stuff down. So if I want to do a new value, I can say new value. It asks which offset you want to modify. Let's just modify offset number 2. Press enter. And then it will ask you for all the numbers for all the axes. So X will do, you know, set it to 0. Y, if I want to leave Y the same, if I don't enter anything, it won't change it. Z, if we want to say, you know, 4.25, enter. And then A and B, I don't have A and B axes. So then, once you enter in, it will show you the old values and the new values, and then you have the option to accept or reject those values. So we'll press 1, we'll accept them, and then you've got your new offsets in there. So then let's take a look at the utilities real quick and see what utilities are in there and how we can use these. So we'll press 3. And now what we're in is we are in the offset utilities, and there's a bunch of them. We can select a number, so we can hit number 1, and it says which fixture offset do you want to modify. So if I want to modify fixture offset number 2, I can type in a 2. Okay? It will ask you what your locator diameter is. So if you're using an edge finder, you would enter in the diameter of your edge finder. If you're using a touch probe, you would enter in the diameter of the tip of your touch probe. So if I'm using an edge finder, my edge finder is 0.2 inches in diameter. I'll enter in 0.2, hit enter. It's going to ask you, what speed do you want to run the spindle at? Well, we'd like to run 500, so we'll enter in 500. And then it says, press start to set the spindle RPM. Press start. It just set our spindle RPM for us. Okay? So now that you've told it that information, it will do all of the math for you. Okay? We can jog to a location, we can store to a location, we can find the center of a circle. So what you can do with your edge finder is if your part's round, it takes 3 points and then it will calculate from those 3 points what's the center of the circle. You can find a midpoint, so if you find 2 edges on a block and you want the midpoint, you can do that. You can find a corner, you can find a 90-degree corner. So there's a lot of utilities in here to help you find basic common geometries, and this will do all the math for you and set those numbers directly into that work offset that you're modifying. So again, this is a time saver versus the manual way, because we're not writing any numbers down, we're just letting the machine do it for us. It also alleviates us from error. How many people have found an edge and then forgot to subtract or add that 0.1 inches from your edge finder diameter? Okay, everybody's done it. If you haven't done it, you're not making enough parts yet. Okay, you will do it eventually. So by letting the machine do that math for you, it will alleviate one source of error, because it's automatically going to subtract or add that edge finder diameter for you. Okay? So that's how we do our work offsets, our fixture offsets. Okay, we got all the nitty-gritty stuff out of the way on how to set up the machine. Let's talk about program maintenance. And there's a lot of stuff here. I'm not going to go over it all. However, there is a very nice option built into the machine called menu. Okay, so menu is accessed by typing in MU. So if I type in MU, enter, it's going to bring up every single possible command there is, and then you can choose to look at a little help file for each one of those commands. So one of the commands is called PR, and it's program maintenance. Let's see here, where is it? I think they call it program library 16. So we type in 16, enter. Okay, so program library maintenance, it's going to say, okay, PR, and you can enter in program memory maintenance, and then the next one is punch program. That's how you get a program out of the machine. So by using MU, there's all self-help built into the machine. So remember MU if you don't remember any other commands, because that one will show you what's possible, and then it will give you a little brief description in how to use those commands. Now some of them are pretty complex and they just say see the manual, which in that case you gotta go read. So let's go into the program maintenance. So we'll type in PR and hit enter. And now this is how we can manage the programs that are currently residing in the machine memory. So if we do a 2, it will display all the programs that are currently in the machine. So we got 2 programs in there. Then we can switch a program, so we can change the programs that we're going to run. We can copy programs, we can delete programs out of the machine. So this is the general how you maintain any of the programs. So if we want to switch a program, we can say 1, and it will ask you which program number do you want to switch. So we'll say program 110 or 1010. And now it's just switched to program 1010. Okay? So that's how you can see what programs are in the machine, delete them, copy them, etc. Now, if you have a program that's in the machine and you want to read that program or modify that program, the next command for doing that is called PA. Okay? So PA, enter, and now it will display the program that's currently in the machine. So this program is the Op10 for the interstage separator retainer. Okay, so that was the last part that we made. So in here we can hit enter and we can page down and you can see all the G code. And then on this screen you have the capability to change a program number or a line in the program, you know, or you can modify, you can change it, you can delete it, you can insert. So this is how you can do simple single line edits of programs. Okay, so that's PA. So say you want to type in and enter in a whole entire program from the machine console here. Now I've got a couple of thoughts on that. My first thought on that is this is not the most ergonomic workstation known to man. It's actually probably one of the least ergonomic workstations known. So why would you want to stand here and type in a whole program? If it's 5 lines, okay, sold. But any more than that, I don't advise you doing that. Number 2 is if you hear about somebody crashing their machine, the vast majority of the time you ask them, well, what happened? It's one of 2 answers. Either A, I tried to resume a program and I resumed it on the wrong line and an offset was not applied. Okay, so that's case 1. Case number 2 is, oh, I was running a program, there was a small error in it, and I edited the program on the machine manually, and then I just ran it, but I accidentally had a typo. So those are the 2 most common causes for machine crashes. With that said, anytime that I modify a program or do any programming changes, I take it offline to my desk. I can do the changes there, make all my modifications, and then because I'm at my desk, I'm going to run my back plotter and I'm going to simulate the program first. Okay? So if I have a typo or I misplaced a decimal point, I will be able to hopefully see that when I run my simulation rather than out on the machine in real life and crash the machine. So that's why I am not a big advocate of modifying programs on the machine. But if you want to do that, here's how we can do that. So we're going to go back into that PA screen, okay? And that's the screen where you can modify and view a program. And now from this PA screen, you can also do some programming functions with the P command. So we'll type in P, and it asks you, what do you want to do? Well, I want to start a new program, so we'll type in 3. It asks you, what program number do you want to call it? We'll call it 100. And then it asks you, what do you want to call the program? So it's going to put a comment in for you to name the program. We'll call it our test program. Okay? So now it's started the program for us. So our very first line is the O program number, and we called it test. So now I can insert as many lines as I want. So I can say I, and I'm not writing a real program, I'm just kind of showing you how to use the utility. So if I want to say X to 1.0, I can hit enter. If I want to say X to 2.0, I can hit enter. If I want to say X to 3.0, I can hit enter. So you get the idea. You can type and write the whole entire program from the machine console if you want. When you're all done, you hit manual, and then now you have your program. Now, the one thing I will point out in detail is here, this one really threw me for a loop. So say I want to change this last line, I'll use the C command for change, and say I want to say, okay, at X3 I also want to go Y 1.0. Okay? Now, it's X3, Y1. What happens if you want to say, no, I don't want to move X at that point anymore, I only want to move Y. So we're going to hit change again. How do you remove the X axis call? I beat my head against the desk for a while trying to figure this out, and I still forget how to do it sometimes. So if you have an element on a line that you want to remove, you have to type in that element and then a semicolon. It makes absolutely no sense. So if I just want Y1 to be on that line, I need to type in X semicolon and hit enter. Okay, now it deleted the X command. Okay, so that's how you can delete a segment of a line. So if you have a G command in there, say you have a G1, you can type in G1 semicolon, it will remove the G1. So the semicolon is how you can remove a parameter off of a line. So remember that one. Last topic that we'll cover in our basic machine operation. Remember, I'm just trying to cover the basics to get people up and running, you know, with the machine, with the Fadal specifically. You can read the manuals. There's a lot more in these machines than just what I'm covering. I'm just doing the basics. So the last thing I want to cover is a lot of people are now using CAM. So like we discussed previous, we do our programming offline at our desk, and then we want to bring the program to the machine and put it on the machine and run it. So how do you do that? Okay, so the first thing you're going to need is you're going to need at least a computer with a native serial port. And those are becoming harder and harder to find. Laptops don't come with serial ports anymore. There are very few USB serial ports that will actually work with these machines. And I believe it has to do with flow control. So these machines use software flow control. It's called X on, X off type of flow control. So there's two characters, it's called X on and X off, how novel, that are sent between the PC and the machine to control the flow of data. So today's computers are so fast that they can easily overwhelm these machines with data. So the machine will yell at the computer and say, oh, stop, 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 you know, slow down, I can't take the data that fast while it's processing the data. And then when the machine's ready to receive more data, it will say, okay, you can send more, and then your PC will send more to it. The USB interfaces mess that up somehow, and I'm not entirely sure how it gets messed up, but very few of them actually work. So you really need to find a computer with a native hardware built-in serial port. That will work. So that's step one. Step two is you need some software to be able to send the program to the machine. Now that software can actually be pretty stupid simple. Some of the terminal emulator programs can actually do it. All you need is to be able to take a file, and the file needs to start with a % and end with a %, and then your code's in the middle, and just send that file as is out the serial port, ASCII format, and be able to use X on, X off flow control. That's all you need, okay? There are some DNC programs that do a lot more that are pretty pricey. They can get up to a couple $100. There's some freeware DNC software that I have never been able to get to work, and then there's some cheaper stuff that, you know, I never even bothered trying to buy. There's lots of options. I'm going to try to get together another option. I'm working with a viewer now. He's the guinea pig. He's being the test subject. I took the software that I wrote for my embedded controller. We did a video on how I did this embedded controller for my specific machine application, and I'm writing it for the PC now. So it will be able to send a program to the machine and then also DNC a program to the machine using drip feed method. Okay? We may expand it beyond that if I get more requests. I don't know if I'm going to give it away for free yet. I'm still deciding on that. I might just give it away. We'll see on that one. In any event, once you have a computer with software that can send the information to the machine, all you have to do on the machine side to send a program to the machine is type in TA, 1. Okay? And that stands for tape input. Now, why is it called tape input? Well, when these machines were made and designed originally, they literally had cassette tape decks that would store the program, and you would put the tape in the, you know, cassette tape deck player. Some people may not even remember what a cassette tape looks like anymore. They're that old. And then you would tell the machine, okay, it's tape input, TA, 1, and then you would press start on the tape drive, and then it would start the tape drive and stream the data to the machine, and the machine would start and stop the tape with the flow control, and, you know, it worked. Okay? So on the machine console, you type in TA, 1. The machine will then go into a waiting mode, and it's waiting to see a %. So that's why your program must contain a % at the top. Then once it sees the %, it will start taking in that program, and it will recognize the O number. The next line on the program must be an O and a number, and that will be the program number that the machine will store it in. And then when it sees another %, it will stop, and it will say, okay, program done. Now, I highly advise you, after you do the TA, 1, is that you do command VT, which is called verify tape. And then you can resend the exact same program, and it will tell you if the program is verified. Now, I will say, I have had programs sent to the machine, and I haven't figured out why yet. I'm still working on that puzzle, where the program went into the machine just fine. There are no errors in the program. However, when you do the verify, it will not verify. And I think it has to do with some character that was generated from the CAM code that the machine doesn't like or doesn't store, and then the way that it does its verification, it includes that character when you go to verify, but it doesn't include it when you go to program it, so then it butts heads and it won't verify. Doesn't necessarily mean the program's bad. I've had it happen multiple occasions, so keep that in mind as well. Now, if there's a program that's in the machine and you want to get it out, again, you just need to set your computer up to be the catcher or the receiver, And flow control really isn't that important here because the machines are a lot slower than the computers. The computers will just take the serial data stream and crunch it right away. But again, it uses X on, X off flow control. And then the machine, you type in PU, which is punch program. And that kind of goes back to the days of punch cards. So we're getting really dated here. So it's tape input and punch. Now, in addition to the programs, you can also punch out and input in your tool offset tables. So if you want to keep track of all your tool numbers and your tool offsets, you can store that in a database, and then if you want to get fancy, you can have it send it to the machine as well. You can do it for fixture offsets. You can get the survey data out of the machine, and then if you really want to get fancy and you really want to, go whole hog into this thing, there are methods and ways that you can actually operate just about the whole entire machine through the RS-232 port. Okay? So, very versatile there. But remember, TA, 1 to put a program in the machine, PU to get the program out of the machine. Okay, last one. A lot of these machines don't have a lot of memory. So this machine specifically has 44K of memory. I have only a few CAM generated codes that will fit in my machine memory. 95% of them will not fit within 44K of memory. It just will not fit, period. However, all hope is not lost. There's something called DNC, or it's direct numerical control. And basically what you're doing is you're setting up the computer to then stream the program through the serial port as it's running in real time. So as the machine is receiving commands, it's going to execute those commands, the machine's going to move, and it's going to make your part. Okay? So in that case, the program can be as big as you want. It could be a gigabyte. It'll just sit here and stream it. There are some caveats to this, though. You can only fit so many blocks through that serial port at a given time. The machine can only execute so many blocks at a given time. So if you're doing some really fine detail 3D contouring and you're trying to achieve 100 inches per minute, that's why I say this machine's probably not going to do it. The processor inside is just not fast enough to process all those blocks and be able to generate that 3D toolpath effectively. You'll do what's called starvation, okay? So what you'll see on the screen is normally when you're DNCing a program, you'll see all the lines that are coming up. If you starve the machine, it'll go and you'll only see 2 lines. The one that it's running and the next one. That's it, okay? And what will happen is the machine movement will get real jerky and it will stop and start, and then your part finishes and your cutter life go to all heck, okay? So you have to be careful when you're DNCing that you don't starve the machine. Now these machines support 2 versions of DNC. One's called DNC, which is just your standard DNC, sends it through the serial port. It uses parity checking for your error checking. If there's an error and the parity doesn't catch it, and it says, X go to, 10 or Z go to -5, you could crash. It doesn't happen a lot, but the possibility is there. Another version of the DNC is called DNCX, where it uses a protocol called X modem. Now, X modem is a packetized protocol where the program is packetized in 128 byte blocks, and then each block has a block number and it has a checksum associated with it. So if there's an error in that block, the machine will tell your PC to retransmit that block, and it's error correcting. So it's a much more robust, albeit not foolproof. X modem is very loose on the way that it calculates its checksum. So if you get a lot of errors, if you're in a high noise environment, you have the possibility of getting a packet that is wrong, but the checksum doesn't reflect it. Okay, but it goes a lot farther along than just the standard DNC. So all of my programs I use DNCX on, okay, and that uses the X modem protocol. So those are the ways that we can get the programs in and out of the machine, and how we can run programs that are too big to fit within the machine. So now that we covered all of the basic operation parameters of a Fadal, we need to turn it off at the end of the day. I like to turn mine off at the end of the day. It doesn't do it any good to sit here idle that I can think of, okay? So there's one procedure that you can do to make it easier when you come in the next morning to start the machine up, and that's to send it to its cold start position while it's on, okay? So if you set the tool coordinate offset system, the first thing you want to do is you want to type in set CS, okay? That's set cold start. What that's going to do is it's going to set the tool coordinate system back to the machine coordinate system. So Z0 will be 0, XY0 will be 0 again, okay? So we'll type in set CS, set cold start. Okay, now it wiped out whatever tool coordinate system offset that you previously had programmed in there. Then what you want to do is you want to tell the machine to go to home. So we're going to type in HO and then hit enter. Now my machine's already at home, that's why it just flashed through. If it's not at home, it will say please press the start button. So it's waiting for you to make sure that you're clear of the machine, and then you press the start button and the machine will move to home, which is now back to the cold start position. Now it's just a matter of going to the back of the machine, turning off the disconnect, and then your machine's off. Now the nice part about that is when you come in the next morning and you turn that disconnect back on, your axes shouldn't move. The Z head is counterbalanced and the table should just sit there. So unless you have an earthquake or some, strange event that shifts your axes, you should be able to just come in, double check real quick that you're lined up with all your cold start tabs, turn it on, hit CS and go. Okay, so important step when you're shutting down, just makes life easier the next morning. Okay, so that should just about wrap up this video on general operations for a Fadal VMC. Now this was really high level, but I tried to cover everything that you need to walk in and operate a Fadal and make a part. There's a whole bunch more stuff that these machines can do and can run, and over time I'll try to make some more videos and get into the little bit nitty-gritty. So if there was something that you were hoping that I would cover and I didn't, leave some comments below or send me an email, and I have a list of video requests from viewers that I'm kind of working my way through to get you out the information that you're looking for. So thanks for watching. If you're supporting our channel, thank you very much for supporting us, and we'll see you on the next video.